Hi, and welcome to the presentation of our COMP205P Scenario Week project. We are Alex, Berat, Georgiana, and Jonwin, Team L of the second Scenario Week from our Systems Engineering module at UCL. In this video, we are going to present our two website versions that we have created in order to show security vulnerabilities and the solutions to fix each one of them. Our main functionalities are to register and log in users, type in and display snippets, and upload files. For the deployment of our website, we have used Microsoft Azure. Unauthenticated users can see registered usernames along with their most recent snippet on the opening page of our website. To access further features, users need to register by picking a username and a password. After registration, users can log in using their credentials. After logging in, users can create a snippet on the new snippet page. After clicking Publish, the snippet gets displayed on the My Snippets page. Users can also delete their snippets by entering the snippet's number and clicking the Delete button. Users can upload and display files by going to the Upload page. So let's choose a file and click Upload. And we can view the file. They can also display their user IDs, usernames, icon URLs, homepage URLs, profile colors, and private snippets on the profile page. And they can also edit this info except user ID, which remains unchangeable. Users can also change their password by typing the old and new passwords. Regarding the security aspect, we have experimented with 10 vulnerabilities on our beta version. Additionally, we have fixed them on our final deployment version of the website. This is the OWASP Top 10 list in 2010. Injection. By poor planning of the security configuration of the login system, a user could exploit the password field to enter a password that would bypass actual credentials checking. For example, we just signed in with Sophia's actual credentials and we can check her profile. But if we sign out, on the insecure version of the website, we can sign in on Sophia's account by using a password that looks exactly like an SQL query. This SQL query is always true and it tricks the database into letting the attacker sign in without entering the actual password. This signs the attacker into the first account of the database, which is usually an admin. Therefore, this breach can become much more dangerous than it sounds. The attacker could at least steal the user's personal data. If we move over to the database, we can see that it is the first account in the list. The solution would be to separate the username verification and password verification processes. First, check if the username exists, and if it does, only afterwards check for the password. Also, we could use the function realEscapeString to create legal SQL strings in SQL statements. Broken authentication and session management. Passwords are stored without any encryption or hashing. They can easily be hacked and get stolen. In case of a security breach, all passwords will be visible to the person who breaches the security. To implement password hashing on our website, we use PHP's built-in password hash function, which hashes the password when a user registers to the website. To unhash and verify a password when a user signs in, we use PHP's built-in password verify function, which also helps to prevent SQL injection. Another problem is that users might choose the same word for both password and username, which makes it easier to hack in this user's account. They might also try to create accounts with the same username as others. To prevent this, we are making sure that the users do not set the same word for both fields and check if the username is already taken. Users could also try to navigate to a page through typing in a URL and see the content of that page, or probably get a PHP warning displayed on the screen which may expose sensitive information about a website's code. In case of failing proper session management, users can navigate to a page through typing a URL and see the content of that page, or probably get a PHP warning displayed on the screen, which may expose sensitive information about the website's code. To fix this, we navigate all website visitors to the index page if they try to reach a page which requires authentication. Cross-site scripting. By exploiting the new snippet functionality, an attacker can type in JavaScript which can execute once the snippet is posted, and the user loads the snippet into his browser. One potential solution is to strip all the tags when a snippet is entered, such that no script can be displayed to the users. We decided to do this by making use of the strip tags PHP function, which removes all the tags which can start a script. By allowing users to upload any type of file on our website, we leave it vulnerable to access attacks by uploading .html files which contain malicious scripts. To fix this, we can simply prevent users from uploading HTML and JavaScript files. Insecure direct object references. If passwords were stored in a file which was accessible by typing the file's path in the URL, that means that a website is vulnerable to insecure direct object reference attacks. To avoid this, we do not store usernames and passwords in a file which can be accessible via URL, but rather in a database. Security misconfiguration. Use of out-of-date software is one of the major reasons which may lead to security vulnerabilities. It is very important to keep the software up to date to benefit from the new features of the technologies that the website uses. Sensitive data exposure. On our vulnerable website, every time a user creates an account, our system stores his data in a file called user profile. If an attacker knows or doubts that such a file exists, he can simply type in the file path in the browser address bar. Once again, the solution is to store sensitive data in a secure database. Missing function level access control. Unlike on our beta version, we are strictly checking if a user is an admin or not when granting access to admin pages. Cross-site request forgery. After having logged in, if an attacker uploads a snippet with the following content, that snippet displays a reference to the logout button. Other users which see the snippet on the home page will be automatically logged out. What we can do to prevent a CSRF attack on GET and POST requests is to include a random token, which is a unique string generated for each session with each request, and put it in every form as a hidden input. The system will check if the form is valid by comparing the token with the one stored in the user session variable. This means in order to generate a request, the attacker would have to know the token value. Using components with known vulnerabilities. For our project, we have focused on the past vulnerabilities found for HTML5. Thus, we have led various attacks such as code injection and XSS based on a series of documented vulnerabilities. In order to stop the injection and XSS attacks, we added more security features to our backend code. This prevented the users to introduce inputs with specific tags that would normally affect the proper functionality of our application. Unvalidated redirects and forwards. Without having a link checker to determine whether or not the website to which the link redirects toward is safe to access, somebody can exploit that new snippet functionality and type and redirect users to unsafe websites that can perform phishing and install malware. We considered that one way to fix this issue would be to add a cleaner function in the new snippet PHP file, which replaces any URLs by a blank space.